This is Adriana, and there is one thing I can tell you. I hope she tells us too. What you're going to see was elected for the best diploma in the world this year. So check it out.
Okay, so now I can only disappoint you after this, but yeah, my name is Adriana Debnárová, and I finished recently, I graduated from Academy of Fine Arts here in Bratislava, and I would like to present you my master thesis. The subject of my thesis was not primarily generative design or emergent processes, but I think in the end the thesis has something in common with this idea, and we will get to that. Subject of my diploma thesis, as you can see, was architecture in extreme environment. And I was focusing on the relationships between the built form and the environment, and I was trying to address a quite simple question: how could we actually improve the building process in the way that we use more the benefits of the environment and specific weather conditions. I was also not designing final design or final form, but rather focusing on finding some kind of tool and some kind of process which I set in motion. And the design or the final architecture is in fact just a byproduct of this process, and the architecture has to be literally dug out. But at the beginning, I would like to show you another project which I did before my thesis, and which influenced me in the way of thinking about the building or construction process. I first came across the architecture for extreme environment during my internship in Copenhagen, where I had the opportunity to work in a company which was dealing with constructions or structures for Greenland or for polar areas, also extremely cold areas. And the project on which I was participating was the construction of base stations for researchers, which should have been built on the coast of Antarctica. Our main aim, or our main goal there, was to minimize the environmental impact, because if you think of it, in the last 20 years, there was exponential boom in this research or tourist base stations in this area, and the material which got there by building these stations never came back, and the material is just alien or foreign for this continent. So to achieve the minimal environmental impact, we decided not to build the base station by traditional means, but rather to create it by subtracting material. So from a floating iceberg. I forgot to mention that the base station was meant to be built on a floating iceberg, a really gigantic one. So so the base station was created by excavating, using the excavators excavating from these compressed layers of snow and ice, and therefore the final geometry of the interiors is influenced by this elliptical movement of excavator arms, which are marking the limits of the arm movement. But what I liked most about the project was that extreme environment was regarded like an ecosystem was forming unity with the architecture. The design process doesn't primarily deal with building design, but it but it's controlled by this external environment and energy flows which are necessary for internal functions. The architecture does not isolate itself from the environment, but is fundamentally part of it. This project has also really strong environmental aspect, because we picked existing iceberg, which we followed during several years on its journey around the Antarctica coast. And all the sustainability was planned so that this iceberg was meant to host the researchers and tourists for 7 to 10 years until the mass of the iceberg melts so much that it's not inhabitable anymore. And after a few more years, melts completely, and there is nothing left from architecture than just water. So, influenced by these ideas, I decided to set my project in another type of extreme environment, which would be the desert. I decided to pick the desert from more reasons, but first of all, the desert was always a platform for experimenting. It's also a place of paradox, because on one hand you have scarcity of resources like water or any traditional building materials, and also its harsh weather conditions doesn't allow really almost any human activity there. But on the other hand, there is no limit to possibilities and opportunities that can emerge in this area, which has no program or function. These almost other planet-like conditions are calling for radical scarcity management and redistribution of existing potential energies and materials, which I felt could be done by using advanced manufacturing techniques. Also, there is this problem, maybe the largest problem in the world right now, which concerns the area, and it's the spreading of the desert itself, or so-called desertification. Because many parts of the world suffer this desertification, but this problem is most evident in sub-Saharan Africa, in this strip which is called Sahel. This semi-arid area has been subjected to overpopulation, excessive usage of water resources, and unsuitable agriculture throughout the last 60 years. And the result is desertification and starvation of local population. The speed on which is this happening is not negligible at all, because in fact dunes in Sahara can move up to 600 meters per year. So that this literally means that Sahara is taking more than 1 meter of arid earth per day. So on this picture you can see that these are the villages in sub-Saharan Africa, and always around this small settlement you can see this mound of sand dunes, which endangers the people and their and also it keeps the village from growth. So of course the local people are using some kind of defense against this this phenomenon, and they are building this kind of nets on top of the active sand dunes. The nets have this rectangular shape, and they are made out of biological material like tree branches or any other plants. But one problem with this solution is that this material it's not so common in this area, and it's really scarce as well, like any other material. And also poor local people often collect this wood or this biological material to obtain firewood to use in the kitchen. But this solution works in the way that it keeps the sand grain from being blown out from the surface of the sand dune. So for my project, I selected a specific area near the sub-Saharan city Timbuktu in Mali. I have found satellite imagery which are showing the specific area on the north of the city between the years of 2003 and 13, and I wanted to compare it and to find by myself how the dunes are moving, if they are moving at all. So I have the idea of the location in which I am setting my project. What I have found out that the dunes are indeed moving, but they are moving really in uneven way. So some of them just few meters per year, some of them hundreds of meters. And in fact, that this sea of sand dunes, it's almost like abstract and abstract dynamic organism. And this was the time when I decided that the building method which I am suggesting here has to keep the pace with the environment and also be dynamic as well. So I didn't have any experience with robotics and so on, but I decided I am going to build a robot which will help to build some constructions on this site. So initially, the idea was to build some kind of robot on a basis of delta bot, which I felt that its movement or movement of its arms, it's much closer to the geometry of the sand dunes than any other 3D printing principles which are using rather Cartesian grid coordinates. After a couple of weeks of fighting, so this was the plan, and after a couple of weeks I was able to get to something like this. It is really super cheap and shabby looking model of DeltaBot, but it was kind of working. Actually, it was working, and initially I started to do some tests with it. I attached a glue extruder to the middle platform, which is carried by these 3 arms. And this middle platform follows basically any given curve. And I was printing basically with the glue into the sand. Soon I realized that there are at least 2 ways how to print in the sand. One way would be to print layer after layer into the sand and then cover it with another sand layer, then another glue layer. So the classic 3D printing method, or the method could be that I already have some amount of sand and I'm printing on top of the surface, so I'm getting some spaces inside as well. So these are the material tests which I did. Of course, the result depends mostly on different factors, also on the consistency and on the kind of binding material, on the kind of sand which I was using, the grain material, and so on. But soon I realized that, yeah, of course, these material tests were fun, and I was getting these interesting shapes. But the project was still really far away from the issue which I was trying to address, and it was to create the building process which could be implemented into this design of extreme environment. Because to achieve this, I needed to take in consideration much more parameters. First of all, I am in a place where there is no infrastructure and lack of resources, which makes import of any additional material very difficult, if not impossible. So the only way to design something here was to exclusively use the material and the energy which already exists in this area. So I think you know where I'm getting it. I was only focusing on on the material which is sand and on the energy which is the most common energy in Sahara, which is the sun energy. So the idea of using the sun energy on the concentrated sun rays is not entirely new. I think most of you know the Marcus Kaiser project, where he was building basically this low-tech 3D printing machine out of huge Fresnel lens and the sandbox. In fact, this idea is here, at least since 60s, where I have seen a really funny project about how they were imagining the future way of building highways in California by using this huge sand lens, the lens, and melting these stripes of desert to get solid surface for cars to move on. So, of course, when I wanted to use the sun energy, I needed to reorganize the machine as well. I needed to get a completely different machine because I needed. I cannot have any shadow covering the middle platform, which would be carrying the lens, which will be my basically my printing head. So after a couple of trials and models, I selected the one which suit best these requirements. And again, I did this little bit better test model of movement in smaller scale. So how would the machine look like in a real scale? I was thinking that the machine could work on the basis of 3 solar-powered electromotors, moving 3 arms, and these 3 arms are translating to movement to the middle platform, which carries this really strong Fresnel lens. This lens, in an environment like a Sahara, in these conditions, can concentrate sun rays and can achieve a really strong sunbeam, which can reach the temperature more than 1,500 degrees, and which is the melting point of sand. So the individual sun grains will melt together, and after cooling down, they create a stiff material, which is basically silica-based. Of course, the machine, depending on its geometry and kinematics, has some limited working area, and after I don't know if you've seen these orange lines, these are the working area, and after it finishes the work in this working area or solidifying the dunes in the working area, it needs to be somehow transferred to another working area where it can continue its work. So in order to make the machine as autonomous as possible, it would be ideal to that the robot or the machine can move autonomously around the landscape. So, with no need of people dismantling it and constructing it a few meters away. The movement of this 3-legged machine could be quite tricky, because to move the middle platform, the three motors need to be anchored rigidly in the ground, so that only the lens moves. But however, when the machine transfers from one triangular working place to another, it could take usage of the middle platform like the 4th leg, and so this way it could be always anchored on 3 points, and 1 point would be shifting, would be pulling the legs or rotating the legs, and this kind of clumsy way it could climb from one working area to another. So how could this dynamic process look in the time? First, what we have is this plane surface, plane landscape of dunes. Then the robot comes and it's creating the first layer of solidified mesh on top of the dunes. In order to make the surface of the dunes after excavation more stable, I decided to add this additional layer, which could be like a structural layer. Basically, these lines are copying the stress lines of a shell surface with equal geometry, like this dune landscape. And another layers could be added on top of this layer. But this layer before the inside of the dune is hollowed can help to slow down the movement of the dunes in critical areas. So it can supply this material wooden grid, which are the people building traditionally in these areas. Additional layers of the mesh can be added about the area of which are supposed to be inhabitable, and robot can print different patterns according to the structural and programmatic needs. The structure, which is here, resembles structure of geometry of desertos or calcifying bacteria, which turns the sand into sandstone, and this creates a porous structure which could provide shadow as well as circulation of the air for cooling and for inhabitable spaces. Of course, after some time, there will be more and more sand accumulating on one side of the dune, so the process has to be repeated more times. And this way, I will get again more porous and structure, and that's better to create a shadow and microclimate. Part of the loose sand, as I said, could be either dug out or could be just naturally blown out by wind. And inside spaces could host human activities as well as gardens. And plants will be able to grow underneath the less dense meshes, which will provide the needed shadow and protection against harsh winds. So this picture is a cross-section of the landscape at the final stage of the project. The structure that is left creates different and odd spaces. Some of them could be used like shelter for people, some kind of discovered architecture which is dug out of loose sand. If the melted structure is strong enough, it can create a roof, both covered or perforated roof. These architectural spaces are able to accommodate the people, as I said, or other spaces would be created like byproduct of the solidifying of the surface. The spaces which are too small or unsuitable for a human will provide the sun shelter for plants. There is a misconception that the plants cannot actually grow in these areas because of lack of moisture, but there is moisture in mostly underneath the surface. Problem is the UV light, which burns bacteria necessary for plants, and strong wind, which will easily rip out the plant with its roots. In the structure, this structure can soften the direct sunshine and provide shelter for the winds, at the same time collecting the moisture from morning condensation and so on. Yes. So the geometry of the solidified mesh follows natural geometry of the sand dunes, but the sea of dunes is ever changing, so the resulting structure is not specific design following any certain blueprint, but rather transcription of choreography between the dynamic agents, the sand, the wind, and the robot. Yeah. So, as you can see, this is the project for a really more distant future, but it can have some really realistic qualities. Of course, there is a lot of details to solve, like exact shape and size of the lens, or leg grips, or which will allow to stay the robot stable on also steeper slopes, and so on. So this project is just an idea now, but as I said, for the more distant future, I can see maybe the similar robots swarming around Sahara villages, slowly but tirelessly solidifying the dunes and creating the oasis. Thank you. Well, I know that many issues in the project I just scratched on the surface, you know, but in the end, there is also always this gap between the theoretical project and the realization. So I cannot really say how the material which will behave in reality. But you're perfectly right that this is a glass material which will again have some specific properties in this extreme environment. Also, there is the issue of again maybe erosion or some kind of other distortion. Yeah, this is for maybe continuation of the project, if it would be possible in the real environment. Okay, so thank you.
And I also want to thank you that you accepted.